So good afternoon, everyone. I'm Maryse DROUIN. I'm a postdoctoral student in M2P2 laboratory of Aix-Marseille University. And today I will discuss a part of my PhD research. We talked about the exhaust gas wastewater treatment by membrane processes in application to maritime transportation, because the PhD has been made in collaboration with the CMA-CGM, which is a leader in maritime transportation worldwide. Yeah. So maritime transportation represents today more than 80% of the international exchange. It allows the exchange of large volume of goods between the countries, but with the environment today, there is stricter regulation set by the International Maritime Organization to reduce the environmental impact of the shipping industry. In this context, in 2020, which is the beginning of the PhD, there is stricter sulfur oxide emission regulation in maritime application in open seas, where the sulfur equivalent decreased from 3.5% equivalent to 0.5% equivalent in open seas, so in large sea. In this context, and to be compliant with the new regulation, the ship owners of the maritime transportation have to adapt their vessel and avoid to usage heavy fuel with high sulfur percentage inside. And some vessels of the CMA-CGM have been retrofitted with hybrid exhaust gas system. So why the hybrid exhaust gas system? This system are absorption column with liquid to gas absorption, can be able to run either in open loop with a single contact between the alkaline water and the polluted gas to reach the 0.5 sulfur equivalent in the outlet gas, or also able to run in closed loop in more controlled area, like in port and coastal area. In this kind of operation, the wash water recirculated continuously inside the absorption column, and a higher sulfur ratio can be reached at the gas outlet. We are able to reach a lower ratio because we have a slurry addition of alkaline compound here to improve the scrubbing properties of the water, and then we have a water treatment unit installed after to be able to reject the water in a natural environment. This combination between exhaust gas and water treatment is something new to be implanted on board, and needs some improvement to have a better management of both units. On our research, we mainly focus on the water treatment unit. So the water treatment unit is installed to reduce the suspended solid inside the process tank and help for better scrubbing properties of the gas. It also helps to discharge a good water quality to the natural environment, respecting the IMO discharge regulation, and also be able to limit the volume of wastewater to be stored on board during the navigation of the vessel. It is composed of pre-treatment step with a precipitation of hydrocyclone combining and a membrane processes which allows to a large rejection of the water. The objectives of this study is to develop and optimize the water treatment unit operation by studying the membrane fouling and the selectivity, studying also the flexibility of the unit among the navigation. To do this, we are designed a membrane filtration skid, which is able to work as similar as the onboard unit directly installed and used today. We use some silicon carbide multi-tubular membrane, so mineral membrane with a pore diameter of 0.2 micrometers, and we use real feed water directly sampled on board of process tank inside of the vessel, of the ship, during the navigation. So we have a large variability of feed water tested in semi-industrial scales, which allows to have a categorization of fouling properties of the water and categorization of the membrane performances So we have decided to classify it in three parts. So high fouling water, as you can see here, medium fouling water, and low fouling water regarding the membrane performances and membrane behavior around the time. Results are presented with the permeability around the time, and for each case of the fluid property, we have defined some optimum condition able to use during the navigation to reduce the fouling and reduce also the concentrate volume, so increase the recovery rate. As we can see, when we have a lower fouling water, we can increase the permeate flux. We also increase the water recovery rate, which is good because we have more water treated and a lower processed water become dirtier around the time, which is easier for the entire exhaust gas cleaning system management. If we focus now on the high fouling water membrane behavior, we can see here, we test different operating conditions as we change the flux, the frequency of the backwash action, and we observe the performances around the time. We saw that with the permeate flux of 150 liters per hour square meter, we have a high membrane fouling with the filtration which is stopped during the first minute of the filtration here, so before 100 minutes of filtration. When we use a flux of 90 liters per hour square meter, so we reduce the permeate flux with the same frequency of the backwashes, we saw that we have no permeability stabilization. The permeability decrease around the time and continue to decrease. And when we reduce the flux to 60 liters per hour square meter, we have a permeability stabilization, and with a backpulse frequency of 20 minutes, we are able to reduce the irreversible fouling created inside the membrane. So we define some optimum condition, which is a permeate flux of 60 liters per hour square meter with a backpulse of 20 minutes, which in industrial scale gives a water recovery of 75%. These parameters have been applied in a real condition during the navigation of the vessel, and with the processed water, so feed water with a varying condition and quality around the time. We saw that with this condition, we have the same membrane behavior, and we are able to run more than 14 hours without stopping the filtration and at maximum transmembrane pressure attained. So the semi-industrial scales parameters defined have been validated during the navigation in industrial scales, and we saw during this test also the flexibility of and the reliability of the membrane unit for the application. We also take some permeate sample to make analysis and see if the discharge criteria are validated. So first, we made some turbidity analysis on permeate sample. We saw that turbidity is always lower than 6 NTU, and there is no suspended solid inside the permeate water. So we conclude, after all the other physical and chemical analysis, that the permeate samples are in line with the discharge regulation fixed by the International Maritime Organization, with a turbidity lower than 25 NTU, a pH higher than 6.5 to limit the acidification, and a ratio of concentration of pH lower than 50 microgram per liter. To complete this analysis, we also make some heavy metal analysis concentration to see if we are able to retain by the membrane processes and the system the heavy metal. We saw that with metal analysis, we have an elimination of more than 90% of majority of the heavy metal during the first minute of the filtration. This retention time increase with the membrane fouling. And we also wanted to know if the backwash action have an impact of the heavy metal concentration. And as you can see here, analysis taken, sample taken before or after the backwash gives the same heavy metal removal. So membrane processes allow the reduction of the rejection of suspended solid hydrocarbons and heavy metal in seawater. So to conclude, the combination between scrubber, so exhaust gas, and membrane processes as a water treatment unit is operational since 2020 on CMS CGM vessel. Some optimization are needed, but it's helped to reduce the atmospheric pollutant emission by reducing the NOx, the SOx, and the particulate matter. It's also be able to reduce the maritime pollution by reducing the hydrocarbons, heavy metal, and suspended metal rejected into the sea, which globally reduce the maritime transportation environmental impact among the navigation. In terms of result of the study shown here, we saw that silicon carbide membrane are able to maintain the filtration for any fluid quality, any variability around the time, and with different navigation conditions. And the water treatment is efficient to reduce the maritime pollution. As we can see, we have 90% of removal of heavy metal and 100% of the suspended solid. The membrane processes during the navigation show the high flexibility and the reliability. That's why the perspective of the study is to try to increase the membrane filtration unit working hour and extend to the Mediterranean Sea to see if we are able to run in continuous during more than 12 days regarding the maritime constraints and the storage on board. This is a part of my postdoctoral research to try to improve the condition to limit the concentrate volume needed to be stored on board directly. And the second perspective is to work on the new membrane material to improve the filtration resistance and the membrane and the metal removal to be higher than current regulation. So thanks for your attention. If you have some questions.